There's a reason why some products launch flawlessly, while others face immediate recalls, refunds, and one-star reviews. And it's not luck. It comes down to quality control decisions made long before production ever starts. Most inventors focus on one thing: does it work? But they completely ignore the engineering choices that determine whether it keeps working. I'm Tavin. After developing over 2,000 products, I can often predict which ones will fail just by looking at the shortcuts taken during development. They're not obvious mistakes. They're subtle compromises, the kind that create ticking time bombs. Today, I'm breaking down the 9 most common quality control shortcuts that destroy otherwise viable products, and how proper engineering oversight prevents every single one. Point 1. Shortcuts 1 to 3. The good enough testing trap. These are the most common and the most dangerous. Shortcut number 1. Skipping accelerated agent tests. The prototype works fine, so testing feels unnecessary. But materials don't fail on day 1. They fail after exposure to UV light, humidity, repeated stress. Without accelerated aging tests, you're guessing how your product performs in 6 months. Shortcut number 2. Testing only at room temperature. Real customers don't live in a lab. Products get left in hot cars, cold garages, outdoor environments. Temperature cycling changes material behavior. Plastics expand, metals contract, adhesives weaken. Room temperature testing gives false confidence. Shortcut number 3. Sample size of 1. One prototype works, so you assume production will too. That's not validation, that's hope. Statistical variation exists in every process. If you're not testing batches, you're blind to real-world variability. Inventors rationalize these shortcuts because testing feels like delay. But here's the hidden failure pattern. Products perform beautifully at launch, then degrade slowly. Cracks form, fits loosen, components fatigue. Senior engineers build testing protocols into development from day 1, not after complaints roll in. Point 2, shortcuts 4 to 6. The material specification gamble. This is where things get expensive. Shortcut 4, choosing the cheapest material. Lower costs feel smart until performance suffers. Materials aren't interchangeable. 2 plastics may look identical and behave completely differently under stress. Shortcut number 5, blind trust in certifications. A supplier says the material is certified, so you assume it meets your needs, but certifications don't guarantee performance for your specific application. Independent validation matters. Shortcut number 6, generic material specifications. ABS plastic, which grade, which melt flow rate, which impact resistance. Generic specs create inconsistency across suppliers and production batches. Inventors assume similar-looking materials will perform the same. Well, they won't. Material shortcuts create compliance risk too. Regulatory agencies require documentation, and when specifications are vague, you can't prove compliance. Experienced engineers specify exact grades with documented properties, and it prevents painful redesigns later. Point 3, shortcuts 7 and 8, the documentation disaster. These feel like administrative details, but they're not. Shortcut number 7, skipping incoming inspection. Suppliers are reliable until they're not. Every production run varies. Incoming inspection protects you from bad batches before they reach customers. Shortcut number 8, verbal quality standards. No written specs, just conversations. That's a disaster waiting to happen. Each supplier interprets requirements differently. Personnel turnover erases agreements. Disputes become unresolvable. Documentation feels slow during development, but it prevents chaos during production. Engineering solution? Detailed inspection procedures, written tolerances, clear acceptance criteria. Quality must be documented, not assumed. If you want to avoid these quality control disasters before they kill your product, I've created a free quality control checklist covering all 9 shortcuts we just discussed. It's based on lessons from developing over 2,000 products, the quality steps that actually matter. So grab it from the link in the description and catch these issues before they become expensive problems. Point 4, shortcut 9, the one that kills everything. This is the biggest misconception. Shortcut 9, assuming factory QC, replaces design phase planning. Inventors think the factory will catch issues. No, quality is built into design specifications. It cannot be inspected into existence later. Manufacturing inspection can catch defects. It cannot fix poor design decisions. And here's the timing reality. By the time you're in production, tooling is committed. Design changes become extremely expensive. If quality problems surface late, they impact entire production runs. Thousands of units units, mass recalls, brand damage. Senior engineering embeds quality requirements into design from day one. Before tooling, before volume, before risk, these 9 shortcuts all feel reasonable during development. They save time, they save money, they reduce friction until they don't. Each shortcut compounds. Small compromises turn into systematic failures. Multi-million-dollar ideas die because quality shortcuts accumulate. Experienced engineering teams prevent this by designing for quality from the beginning, because quality isn't added at the end. It's engineered in at the start. Now that you know the 9 shortcuts that destroy products, you might be wondering, how do I implement proper quality control without decades of experience? That's where working with senior engineers matters. At Rabbit, we help inventors navigate these exact challenges using the same oversight process I described today. If you want to discuss how proper engineering can protect your product from these hidden risks, click the link below to connect with our team. And if this opened your eyes to quality risks you haven't considered, watch my next video where I break down the 3 biggest manufacturing mistakes that turn profitable products into money pits. So click now.